Assalamualaikum and good day. My name is Binti Shah. My metric number is B0918103669. I'm from program PMMV and my final year project title is Development of SEACRETE for Artificial Coral Reef Purpose. My supervisor name is Dr. Muhammad Haizal bin Muhammad Hussein. My slide content is 1 introduction, 2 problem statement, 3 objectives, 4 scope, then we will go to the literature review and the methodology, and lastly, we will go to flowchart. Coral reef is one of the highest biodiversity that give many benefits to the marine ecosystem. But what is actually a coral? Many people have misconception about coral. They think that coral is a rock or a plant, but actually coral is an animal. Coral reef provide millions of people with food, medicine, protection from storms, and revenue from fishing and tourism. It also provides food for about 4,000 species of animals in the sea. But due to environmental changing and our self-human activity, scientists predict that by 2050, 75% of the coral all around the world will be facing a high critical threat levels, while by 2070, 100% of coral will extinct from this world. If all 100% of coral will extinct from this world, it will give a bad effect for our marine ecosystem. So, scientists and researchers are developing a SEACRETE. SEACRETE is actually an ocean concrete, which is a calcium carbonate that has been electrolytically precipitated around a steel frame cathode submerged in seawater and through which an electrical current passes. SEACRETE is a system that will encourage coral growth by creating limestone which are unable to protect the damaged coral reef. Next slide is problem statement. Coral, which is the world's largest underwater ecosystem, is extinct due to environmental and human activity. We can control the human activity, but we cannot control the environmental changing. So, in order to protect the coral, which have a lot of advantage for marine ecosystem, we must build a SEACRETE. The main material in building the SEACRETE is steel, but it is a material that is very easy to corrode, and past study used a carbon steel that cannot withstand the harsh marine environment. So in this study and experiment, I will use a stainless steel type 316L, which is suitable for marine environment. The objective of the research is first to fabricate the SEACRETE sample based on different calcium carbonate, steel frame, and concrete cement mixture ratio under electrodeposition parameter factor in seawater sample medium. Second, to testing the SEACRETE prepared in compression strength for mechanical properties. And lastly, the third one, to characterize the SEACRETE prepared in morphology textures. The scope that covered in this project is fabrication of SEACRETE as artificial coral based on various electric current input and duration time. Next, fabrication of SEACRETE as artificial coral based on different ratio of limestone, cement, and also electrode materials. Next, the SEACRETE sample characterized based on morphology textures. And lastly, the mechanical testing in compression strength for SEACRETE sample. Next slide is literature review. We will go through literature review from the past study, which way they used to produce the SEACRETE. Harry Spanhoff in the Journal of the Biorock Process picturing reef building with electricity used electrodeposition method, which the electrical reef grows the coral on the SEACRETE. A low voltage of direct current will be applied in order to set off the process of electrolytic that will then release a chemical solution. Water is then being broken down at the cathode to form hydrogen and at the anode to form oxygen due to the electrical current. On the steel, limestone mineral will then grow and it will look like a natural coral reef that found in the nature. Next is the literature review from Lausanne, which is the journal is the corrosion behavior of low-alloy steel bar containing chromium and aluminium in coral concrete for ocean construction. The study creates cementing material using concrete mixture ratio, which contains of cement, fly ash, water, water binder, water reducer, and also stainless steel type 316L. After the concrete was cast, the mold will be implanted with the stainless steel type 316L, which is famous in the marine construction. Then, after 28 days, the specimen strength will be tested. This study is focused on the corrosion for the low alloy steel bar that is implanted in the use of SEACRETE. So, it will observe the stainless steel will corrode or not. Next is the literature review from Lin which is mechanical properties of coral concrete. Lin used raw material which are coral debris, coral fragments, and also coral sands. All of these plus the seawater were blended together in a concrete blender. The mixture will then be poured into a inside surface oil mold for compaction on a vibrating table after the mixing procedure, and after the mixture is ready and we can place out the mold, the specimens were then ready to remove from the mold and cure for 56 days in a room temperature. And after that, the specimen will be tested in terms of its mechanical properties for compressive strength. Next is the methodology. This is proposed experimental setup. I will use the electrochemical workstation or can be replaced with alkaline battery because I want the power supply to undergo the electrodeposition method. And the concrete specimen and stainless steel bar will be submerged in the seawater and will be added with calcium carbonate powder. Calcium carbonate powder is added because calcium carbonate powder is the base for our artificial coral reef. The stainless steel bar that will be used in this experiment is 361 stainless steel bar, which is very suitable and also famous in use for marine construction. The concrete specimen will be prepared with a different mixture ratio in order to see which one is more suitable for the growth of the coral reef. Next, we will go through in the first process of making the SEACRETE. I will start by making the cementing material first. The concrete mixture ratio is made from cement, water, water reducer, water binder ratio, and also calcium carbonate powder. The auxiliary electrode, which is the connection for the current that will be used in this experiment, is 316L stainless steel rod. This 316L stainless steel suitable to use as an electrode because it can withstand high temperatures and also high corrosion level. This type of steel is the same with our stainless steel. The casting for the concrete will begin and the mold will be removed after about 24 hours and the concrete will be kept under ordinary conditions for another 28 days. The ordinary condition is like the experiment setup, which we will submerge it in the seawater and will undergo the electroposition methods for another 28 days to see if the coral grow or not. When the coral has grown, the specimen is going to undergo the mechanical testing for me to see whether the SEACRETE is passed or failed. If the SEACRETE test is passed, the mixture ratio is good, and if it is failed, I will repeat it with a different mixture ratio in order to make the SEACRETE is passed and the coral can grow on it. This is the flowchart that I use as the project planning. First, I will identify the material and equipment, and then I will go through the secret preparation by mixing the concrete. If it is passed, I will go to the drying process, and if it is not passed, I will go back to the secret preparation by repeated the mixture ratio with a different volume. Then, if it is passed, I will go to secret sample condition, and I will do a mechanical testing to see if the compression strength is sturdy or not. If it is yes, I will characterize it based on morphology texture by optical microscope. But if the compression strength is not sturdy, I will go back to the mechanical testing and make it sturdy, and then I will go into the next process to characterize it based on morphology texture by optical microscope. And that is the end of the experiment. In a summary, the damage of the coral must have to be settled quickly to secure the marine ecosystem. So the secret development need to be done and passed in order to save the ecosystem. The coral is very important for our ecosystem, not only for marine, since it gives a lot of benefit. And the secret development will be done to repair our environment. Okay. That's all from me. Thank you for hearing my presentation.